Chapter 2: Fundamental Agile Testing Principles, Practices, and Processes. 2.1 The differences between testing in traditional and agile approaches. As described in the foundation level syllabus and in Black 09, test activities are related to development activities, and thus testing varies in different life cycles. Testers must understand the differences between testing in traditional life cycle models, e.g., sequential, such as the V model, or iterative, such as RUP, and agile life cycles, in order to work effectively and efficiently. The agile models differ in terms of the way testing and development activities are integrated, the project work products, the names, entry and exit criteria used for various levels of testing, the use of tools, and how independent testing can be effectively utilized. Testers should remember that organizations vary considerably in their implementation of life cycles. Deviation from the ideals of agile life cycles, see section 1.1, may represent intelligent customization and adaptation of the practices. The ability to adapt to the context of a given project, including the software development practices actually followed, is a key success factor for testers. 2.1.1 Testing and Development Activities. One of the main differences between traditional life cycles and agile life cycles is the idea of very short iterations. Each iteration resulting in working software that delivers features of value to business stakeholders. At the beginning of the project, there is a release planning period. This is followed by a sequence of iterations. At the beginning of each iteration, there is an iteration planning period. Once iteration scope is established, the selected user stories are developed, integrated with the system, and tested. These iterations are highly dynamic, with development, integration, and testing activities taking place throughout each iteration, and with considerable parallelism and overlap. Testing activities occur throughout the iteration, not as a final activity. Testers, developers, and business stakeholders all have a role in testing, as with traditional life cycles. Developers perform unit tests as they develop features from the user stories. Testers then test those features. Business stakeholders also test the stories during implementation. Business stakeholders might use written test cases, but they also might simply experiment with and use the feature in order to provide fast feedback to the development team. In some cases, hardening or stabilization iterations occur periodically to resolve any lingering defects and other forms of technical debt. However, the best practice is that no feature is considered done until it has been integrated and tested with the system. Another good practice is to address defects remaining from the previous iteration at the beginning of the next iteration, as part of the backlog for that iteration, referred to as fix bugs first. However, some complain that this practice results in a situation where the total work to be done in the iteration is unknown, and it will be more difficult to estimate when the remaining features can be done. At the end of the sequence of iterations, there can be a set of release activities to get the software ready for delivery, though in some cases delivery occurs at the end of each iteration. When risk-based testing is used as one of the test strategies, a high-level risk analysis occurs during release planning, with testers often driving that analysis. However, the specific quality risks associated with each iteration are identified and assessed in iteration planning. The risk analysis can influence the sequence of development as well as the priority and depth of testing for the features. It also influences the estimation of the test effort required for each failure, See section 3.2. In some Agile practices, e.g., extreme programming, pairing is used. Pairing can involve testers working together in twos to test a feature. Pairing can also involve a tester working collaboratively with a developer to develop and test a feature. Pairing can be difficult when the test team is distributed, but processes and tools can help enable distributed pairing. For more information on distributed work, see ISTQB-ALTM Syllabus Section 2.8. Testers may also serve as testing and quality coaches within the team, sharing testing knowledge and supporting quality assurance work within the team. This promotes a sense of collective ownership of quality of the product. Test automation at all levels of testing occurs in many Agile teams. And this can mean that testers spend time creating, executing, monitoring, and maintaining automated tests and results. Because of the heavy use of test automation, a higher percentage of the manual testing on Agile projects tends to be done using experience-based and defect-based techniques, such as software attacks, exploratory testing, and error guessing. See ISTQB-ALTA Syllabus, Section 3.3 and 3.4, and ISTQB Foundational Level Section 4.5. While developers will focus on creating unit tests, testers should focus on creating automated integration, system, and system integration tests. This leads to a tendency for Agile teams to favor testers with a strong technical and test automation background. One core Agile principle is that change may occur throughout the project. Therefore, lightweight work product documentation is favored in Agile projects. Changes to existing features have testing implications, especially regression testing implications. The use of automated testing is one way of managing the amount of test effort associated with change. However, it's important that the rate of change not exceed the project team's ability to deal with the risks associated with those changes. 2.1.2 Project Work Products. Project work products of immediate interest to Agile testers typically fall into three categories. 1. Business-oriented work products that describe what is needed, e.g., requirements, specifications, and how to use it, e.g., user documentation. Development work products that describe how the system is built, e.g., database entity, relationship diagrams. That actually implement the system, e.g., code. Or that evaluate individual pieces of code, e.g., automated unit tests. 3. Test work products that describe how the system is tested, e.g., test strategies and plans. That actually test the system, e.g., manual and automated tests. Or that present test results, e.g., test dashboards as discussed in section 2.2.1. In a typical Agile project, it is a common practice to avoid producing vast amounts of documentation. Instead, focus is more on having work software together with automated tests that demonstrate conformance to requirements. This encouragement to reduce documentation applies only to documentation that does not deliver value to the customer. In a successful Agile project, a balance is struck between increasing efficiency by reducing documentation and providing sufficient documentation to support business, testing, development, and maintenance activities. The team must make a decision during release planning about which work products are required and what level of work product documentation is needed. Typical business-oriented work products on Agile projects include user stories and acceptance criteria. User stories are the Agile form of requirement specifications and should explain how the system should behave with respect to a single coherent feature or function. A user story should define a feature small enough to be completed in a single iteration. Larger collections of related features or a collection of subfeatures that make up a single complex feature may be referred to as epics. Epics may include user stories for different development teams. For example, one user story can describe what is required at the API level, middleware, while another story describes what is needed at the UI level, application. These collections may be developed over a series of sprints. Each epic and its user stories should have associated acceptance criteria. Typical developer work products on Agile projects include code. Agile developers also often create automated unit tests. These tests might be created after the development of code. In some cases, though, developers create tests incrementally, before each portion of the code is written, in order to provide a way of verifying, once that portion of code is written, whether it works as expected. While this approach is referred to as test-first or test-driven development, in reality, the tests are more a form of executable low-level design specifications rather than tests. Beck 02. Typical tester work products on Agile projects include automated tests, as well as documents such as test plans, quality risk catalogs, manual tests, defect reports, and test results logs. The documents are captured in as lightweight a fashion as possible, which is often also true of these documents in traditional life cycles. Testers will also produce test metrics from defect reports and test results logs, and again, there is an emphasis on a lightweight approach. In some Agile implementations, specially regulated, safety-critical, distributed, or highly complex projects and products, further formalization of these work products is required. For example, some teams transform user stories and acceptance criteria into more formal requirement specifications. Vertical and horizontal traceability reports may be prepared to satisfy auditors, regulations, and other requirements. 2.1.3 Test Levels. Test levels are test activities that are logically related, often by the maturity or completeness of the item under test. In sequential lifecycle models, the test levels are often defined such that the exit criteria of one level are part of the entry criteria for the next level. In some iterative models, this rule does not apply. Test levels overlap. Requirement specification, design specification, and development activities may overlap with test levels. In some Agile life cycles, overlap occurs because changes to requirements, design, and code can happen at any point in an iteration. While Scrum, in theory, does not allow changes to the user stories after iteration planning, in practice, such changes sometimes occur. During an iteration, any given user story will typically progress sequentially through the following test activities. Unit testing, typically done by the developer. Feature acceptance testing, which is sometimes broken into two activities. Feature verification testing, which is often automated, may be done by developers or testers, and involve testing against the user story's acceptance criteria. Feature validation testing, which is usually manual and can involve developers, testers, and business stakeholders working collaboratively to determine whether the feature is fit for use, to improve visibility of the progress made, and to receive real feedback from the business stakeholders. In addition, there is often a parallel process of regression testing occurring throughout the iteration. This involves rerunning the automated unit tests and feature verification tests from the current iteration and previous iterations. usually via continuous integration framework. In some Agile projects, there may be a system test level, which starts once the first user story is ready for such testing. This can involve executing functional tests, as well as non-functional tests for performance, reliability, usability, and other relevant test types. Agile teams can employ various forms of acceptance testing, using the term as explained in the foundational level syllabus. Internal alpha tests and external beta tests may occur, either at the close of each iteration, after the completion of each iteration, or after a series of iterations. User acceptance tests, operational acceptance tests, regulatory acceptance tests, and contract acceptance tests also may occur, either at the close of each iteration, after the completion of each iteration, or after a series of iterations. 2.1.4 Testing and Configuration Management. Agile projects often involve heavy use of automated tools to develop, test, and manage software development. Developers use tools for static analysis, unit testing, and code coverage. Developers continuously check the code and unit tests into a configuration management system using automated build and test frameworks. These frameworks allow the continuous integration of new software with the system, with the static analysis and unit tests run repeatedly as new software is checked in. These automated tests can also include functional tests at the integration and system levels. Such functional automated tests may be created using functional testing harnesses, open source user interface functional test tools, or commercial tools, and can be integrated with the automated tests run as part of the continuous integration framework. In some cases, due to the duration of the functional tests are separated from the unit tests and run less frequently. For example, unit tests may be run each time new software is checked in, while the longer functional tests are run only every few days. One goal of the automated tests is to confirm that the build is functioning and installable. If any automated test fails, the team should fix the underlying defect in time for the next code check-in. This requires an investment in real-time test reporting to provide good visibility into test results. This approach helps reduce expensive and inefficient cycles of build, install, fail, rebuild, reinstall that can occur in many traditional projects. Since changes that break the build or cause software to fail to install are detected quickly. Automated testing and build tools help to manage the regression risk associated with the frequent change that often occurs in Agile projects. However, over-reliance on automated unit testing alone to manage these risks can be a problem, as unit testing often has limited defect detection effectiveness. Automated tests at the integration and system levels are also required. 2.1.5 Organizational Options for Independent Testing. As discussed in the foundational level syllabus, independent testers are often more effective at finding defects. In some Agile teams, developers create many of the tests in the form of automated tests. One or more testers may be embedded within the team performing many of the testing tasks. However, giving those testers position within the team, there is a risk of loss of independence and objective evaluation. Other Agile teams retain fully independent, separate test teams, and assign testers on demand during the final days of each sprint. This can preserve independence, and these testers can provide an objective, unbiased evaluation of the software. However, time pressures, lack of understanding of the new features in the product, and relationship issues with business stakeholders and developers often lead to problems with this approach. A third option is to have an independent, separate test team where testers are assigned to Agile teams on a long-term basis. At the beginning of the project, allowing them to maintain their independence while gaining a good understanding of the product and strong relationships with other team members. In addition, the independent test team can have specialized testers outside of the Agile teams to work on long-term and/or iteration-independent activities, such as developing automated test tools, carrying out non-functional testing, creating and supporting test environments and data, and carrying out test levels that might not fit well within a sprint, e.g., system integration testing. 2.2 Status of testing in Agile projects. Change takes place rapidly in Agile projects. This change means that test status, test progress, and product quality consistently evolve, and testers must devise ways to get the information to the team so that they can make decisions to stay on track for successful completion of each iteration. In addition, change can affect existing features from previous iterations. Therefore, manual and automated tests must be updated to deal effectively with regression risk. 2.2.1 Communicating test status, progress, and product quality. Agile teams progress by having working software at the end of each iteration. To determine when the team will have working software, they need to monitor the progress of all work items in the iteration and release. Testers in Agile teams utilize various methods to record test progress and status, including test automation results, progression of test tasks and stories on the Agile task board, and burn down charts showing the team's progress. This can then be communicated to the rest of the team using media such as wiki dashboards and dashboard styles email, as well as verbally during stand-up meetings. Agile teams may use tools that automatically generate status reports based on test results and task progress, which in turn update wiki-style dashboards and emails. This method of communication also gathers metrics from the testing process, which can be used in process improvement. Communicating test status in such an automated manner also frees testers' time to focus on designing and executing more test cases. Teams may use burn-down charts to track progress across the entire release and within each iteration. A burn-down chart represents the amount of work left to be done against time allocated to the release or iteration. To provide an instant, detailed visual representation of the whole team's current status, including the status of testing, teams may use Agile task boards. The story cards, development tasks, test tasks, and other tasks created during iteration planning, see section 1.2.5, are captured on the task board, often using color-coordinated cards to determine the task type. During the iteration, progress is managed via the movement of these tasks across the task board into columns such as To Do, Work in Progress, Verify, and Done. Agile teams may use tools to maintain their story cards and Agile task boards, which can automate dashboards and status updates. Testing tasks on the task board relate to the acceptance criteria defined for the user stories. As test automation scripts, manual tests, and exploratory tests for a test task achieve a passing status, the task moves into the Done column of the task board. The whole team reviews the status of the task board regularly, often during the daily stand-up meetings, to ensure tasks are moving across the board at an acceptable rate. If any tasks, including testing tasks, are not moving or are moving too slowly, the team reviews and addresses any issues that may be blocking the progress of those tasks. The daily stand-up meeting includes all members of the Agile team, including testers. At this meeting, they communicate their current status. The agenda for each member is, what have you completed since the last meeting? What do you plan to complete by the next meeting? What is getting in your way? Any issues that may block test progress are communicating during the daily stand-up meetings, so the whole team is aware of the issues and can resolve them accordingly. To improve the overall product quality, many Agile teams perform customer satisfaction surveys to receive feedback on whether the product meets customer expectations. Teams may use other metrics similar to those captured in traditional development methodologies, such as test pass-fail rates, defect discovery rates, confirmation and regression test results, defect density, defects found and fixed, requirements coverage, risk coverage, and code churn to improve the product quality. As with any life cycle, the metrics captured and reported should be relevant and aid decision-making. Metrics should not be used to reward, punish, or isolate any team members. 2.2.2 Managing regression risk with evolving manual and automated test cases. In an Agile project, as each iteration completes, the product grows. Therefore, the scope of testing also increases. Along with testing the code changes made in the current iteration, testers also need to verify no regression has been introduced on features that were developed and tested in previous iterations. The risk of introducing regression in Agile development is high due to extensive code churn, links of code added, modified, or deleted from one version to another. Since responding to change is a key Agile principle, changes can also be made to previously delivered features to meet business needs. In order to maintain velocity without incurring a large amount of technical debt, it is critical that teams invest in test automation at all test levels as early as possible. It is also critical that all test assets, such as automated tests, manual test cases, test data, and other testing artifacts, are kept up to date with each iteration. It is highly recommended that all test assets be maintained in a configuration management tool in order to enable version control, to ensure ease of access by all team members, and to support making changes as required due to changing functionality, while still preserving the historic information of the test assets. Because complete repetition of all tests is seldom possible, especially in tight timeline Agile projects, testers need to allocate time in each iteration to review manual and automated test cases from previous and current iterations to select test cases that may be candidates for the regression test suite, and to retire test cases that are no longer relevant. Tests written in earlier iterations to verify specific features may have little value in later iterations due to feature changes or new features which alter the way those earlier features behave. While reviewing test cases, testers should consider suitability for automation. The team needs to automate as many tests as possible from previous and current iterations. This allows automated regression tests to reduce regression risk with less effort than manual regression testing would require. This reduced regression test effort frees the testers to more thoroughly test new features and functions in the current iteration. It is critical that testers have the ability to quickly identify and update test cases from previous iterations and/or releases that are affected by the changes made in the current iteration. Defining how the team designs, writes, and stores test cases should occur during release planning. Good practices for test design and implementation need to be adopted early and applied consistently. The shorter timeframes for testing and the constant change in each iteration will increase the impact of poor test design and implementation practices. Use of test automation at all test levels allows Agile teams to provide rapid feedback on product quality. Well-written automated tests provide a living document of system functionality. By checking the automated tests and their corresponding test results into the configuration management system, aligned with the versioning of the product builds, Agile teams can review the functionality tested and the test results from any given build at any given point in time. Automated unit tests are run before source code is checked into the main line of the configuration management system to ensure the code changes do not break the software build. To reduce build breaks, which can slow down the progress of the whole team, code should not be checked in unless all automated unit tests pass. Automated unit test results provide immediate feedback on code and build quality, but not on product quality. Automated acceptance tests are run regularly as part of the continuous integration full system build. These tests are run against a complete system build at least daily, but are generally not run with each code check-in, as they take longer to run than automated unit tests and could slow down code check-ins. The test results from automated acceptance tests provide feedback on product quality with respect to regression since the last build, but they do not provide status of overall product quality. Automated tests can be run continuously against the system. An initial subset of automated tests to cover critical system functionality and integration points should be created immediately after a new build is deployed into the test environment. These tests are commonly known as build verification tests. Results from the build verification tests will provide instant feedback on the software after deployment, so teams don't waste time testing an unstable build. Automated tests contained in the regression test set are generally run as part of the daily main build in the continuous integration environment, and again when a new build is deployed into the test environment. As soon as an automated regression test fails, the team stops and investigates the reasons for the failing test. The test may have failed due to legitimate functional changes in the current iteration, in which case the test and/or user story may need to be updated to reflect the new acceptance criteria. Alternatively, the test may need to be retired if another test has been built to cover the changes. However, if the test failed due to a defect, it is a good practice for the team to fix the defect prior to progressing with new features. In addition to test automation, the following testing tasks may also be automated. Test data generation, loading test data into systems, deployment of builds into the test environments, restoration of a test environment, e.g., the database or website data files, to a baseline, comparison of data outputs. Automation of these tasks reduces the overhead and allows the team to spend time developing and testing new features. 2.3 Role and skills of a tester in an Agile team. In an Agile team, testers must closely collaborate with all other team members and with business stakeholders. This has a number of implications in terms of the skills a tester must have and the activities they perform within an Agile team. 2.3.1 Agile tester skills. Agile testers should have all the skills mentioned in the foundational level syllabus in addition to these skills. A tester in an Agile team should be competent in test automation, test-driven development, acceptance test-driven development, white box, black box, and experience-based testing. As Agile methodologies depend heavily on collaboration, communication, and interaction between the team members as well as stakeholders outside the team, testers in an Agile team should have good interpersonal skills. Be positive and solution-oriented with team members and stakeholders. Display critical, quality-oriented, skeptical thinking about the product. Actively acquire information from stakeholders rather than relying entirely on written specifications. Accurately evaluate and report test results, test progress, and product quality. Work effectively to define testable user stories, especially acceptance criteria, with customer representatives and stakeholders. Collaborate within the team, working in pairs with programmers and other team members. Respond to change quickly, including changing, adding, or improving test cases. Plan and organize their own work. Continuous skills growth, including interpersonal skills growth, is essential for all testers, including those on Agile teams. 2.3.2 The role of a tester in an Agile team. The role of a tester in an Agile team includes activities that generate and provide feedback, not only on test status, test progress, and product quality, but also on process quality. In addition to the activities described elsewhere in the syllabus, these activities include understanding, implementing, and updating the test strategy, measuring and reporting test coverage across all applicable coverage dimensions, ensuring proper use of testing tools, configuring, using, and managing test environments and test data, reporting defects and working with the team to resolve them, coaching other team members in relevant aspects of testing, ensuring the appropriate testing tasks are scheduled during release and iteration planning, actively collaborating with developers and business stakeholders to clarify requirements, especially in terms of testability, consistency, and completeness. Participating proactively in team retrospectives, suggesting and implementing improvements. Within an Agile team, each team member is responsible for product quality and plays a role in performing test-related tasks. Agile organizations may encounter some test-related organizational risks. Testers work so closely to developers that they lose the appropriate tester mindset. Testers become tolerant of or silent about inefficient, ineffective, or low-quality practices within the team. Testers cannot keep pace with the incoming changes in time-constrained iterations. To mitigate these risks, organizations may consider variations for preserving independence, discussed in section 2.1.5. Chapter 2 ends.